All right, let's start with some announcements, since there's always a lot going on in this class. Yet another peer review due tonight. I know they suck at this point, but still needed. I finally contacted the grader, which was great. And so we're meeting today. Basically, sprints 2 and 3 are being absolutely finalized. Last little pieces of grade related work is, so those should be in hopefully today. But the work has been done, which is good. I am handing off quizzes that need to be graded today, so that will probably take the rest of the week. I try to have 1 week turnarounds for that, but given that this is a large class, I can't imagine the turnaround is going to happen in 2 days. The grading turnaround is going to happen in 2 days, so I would not expect it. Frustrates me. I would love to give it back to you on Thursday. Other than that, we have 3 weeks now for sprint 4 because of Thanksgiving in there, which is good. And then there's going to be a final code after that. So this is the point where I'm really hoping that the curving happens in the class. I will still curve as needed at the end of the quarter, but if all of those sprint 4 features get implemented over the course of the next 3 weeks, plus the finals week, that will be great. Do note that there will eventually be a presentation in our finals slot for this class, and that will just be a summary of your experience. I recommend going through something like a sprint by sprint. Here is what we did. Here were the issues that we encountered. Here's what we learned from that, and going through kind of a sprint by sprint until you reach, here is where our current project is, and then show off your really cool image of your underlying code and talk about how the code came together at a bit more technical level, what it looks like, how it is built for scalability, how did you utilize the design patterns, what could the client throw at you that you're now ready to handle, and we'll send you off. So that is the rest of the quarter, really. So the end is in sight. I don't know, there's light at the end of the tunnel. Do we feel that way yet in here, or is it still? I don't know. I'm pretty darn proud from the projects that I've seen over the last, since the end of what was submitted for Sprint 3. I think you all have come a very long way this quarter, and these projects are looking really cool, very distinct, and I'm really excited to see those presentations. Because you have a lot to be proud of. Any questions before we dive back into API design?
We'll have quiz 4, right?
At some point, possibly. I reserve the right to cancel quiz 4 if we haven't covered enough material for that, which I'm sure would cause immense amounts of disappointment in the class. All right. Anything else? All right, back into API design we go. Last we talked, we were looking at what is an API, how can we design an API, and what do we need to consider when we do design an API, because you get one chance to get this right, then you can make it extendable, but you cannot make it modifiable because that will break existing code. So really one shot to get it right. We were looking at the issues to consider. We were going into a bit more detail on each of these 3 parts. Started with the interface principles, but then we'll also talk about resource management and error handling. So the interface principles, and we were seeing this at the end of the last period, but we care about your API being simple, general, regular, predictable, robust, and adaptable. All of those are important, but let's re-summarize each of these because I think they're all very important. So simple says that, but remember at this point, you're making a tool that other people, especially other programmers, are going to be utilizing. End users are going to be using. So it needs to be simple enough to use from an outside perspective. the end user should not need to understand what is happening technically underneath the hood in order to connect to and use your API. Your code should do one thing and do it well. You shouldn't have a massive toolbox of a project with an API for all of that. Should be ideally do one thing well. Your API should be as small as possible. You shouldn't have 5 different ways to do the same thing. Only have one way to do that thing, but make sure there is a way to do that. If there is a use case for an end user utilizing your application to do something that they want to do, then there should be some way of doing that. And there should be an interface with documentation that allows them to do that. Yeah, don't provide 3 ways to do the same thing. Avoid long parameter lists. Don't make the user pass in a bunch of information. Find some way of simplifying this. So even in the design of the API, you can find ways to make your end user's life easier. A lot of computer science is design. We see that with something like the user interface design that we've been working on all quarter. We see it in terms of the code design, things like where do we put design patterns that allow for scalability? How do we ensure that we can swap out a view for another view? How have we designed for that? But then your API also has design in it as well. Make sure of all of these things. It should be general. This means that while the underlying implementation can and should change, the API won't change. So it needs to be general enough to be able to do that. It should hide as much information as possible. This is as much for your intellectual property as it is for security. Both of those are the main reasons that you don't want any implementation detail to leak into your API. If an end user of your program understands how it was made, then they can reproduce it. And also anyone who has nefarious end goals has some knowledge about how to maybe do something that you would not like to be done to your code. Certainly minimize accessibility, so keep encapsulation. So classes should be private where possible. Fields and methods, private where needed. Don't just make everything public. And of course, we're seeing this with the clients, although I think the client can do a better job of this, that implementation details can confuse users. So assume that the end users don't know anything and make sure that your documentation, your API is designed to be used by people without your skill set. The client really needs to role play better that there is no technical understanding. And when someone says something that is technical in nature, what is that? Why are you saying that? That makes no sense to me. But at the same time, an end user of your tool, imagine that you're making something like, I'll use my wife's jobs example. Imagine that you're making accounting software to be used by accountants. Accountants are excellent at Excel, but at actual utilizing programming languages, you would want to make sure that if you have an API for someone who can script something, maybe they took an intro CS course and can write a quick Python script that utilizes your API, but they don't understand complex data structures. They don't understand complex algorithms. It should be plug and play with the API for someone who knows how to just put this there. Great. No knowledge needed to be able to do that. So minimize the amount of detail. Yeah, what is implementation? Don't overspecify behavior of modules. Regular says that you're doing the same thing the same way everywhere. That means that parameter ordering should be the same. Return types of similar functions should be the same. Errors should error the same way with the same kind of message and the same style of message. if you free memory in one case, you should free memory in all similar cases, so that the user doesn't have to worry about something that is that is their responsibility here, but it's not their responsibility there. Everything matters with regards to your names for readability. You know this with regards to code, but it's also the case when you're designing an API. If you name your parameters that you're expecting something that the user can understand what it is without reading the description, then your API will get more use. Because I can just look at the method signature and know immediately what the inputs are and what it's returning, because the names of all of those variables are common sense. They're straightforward. There's no interpretation that's needed. Whereas if there is interpretation that's needed, then I'm digging into the weeds of the description of what the method does, possibly confusing myself, possibly misusing it, using it incorrectly, which will lead to frustration and people not wanting to use your tool solely because of the obfuscation of the API. Part of this is the same word means the same thing. The same naming style is used. This means that if you have a reasonably ambiguous word, like what's a good example of an ambiguous variable name that can have multiple different meanings depending on where it's used within the API? Count. Value, count. Yeah. If you're using something that is particularly vague in nature, then make sure that it doesn't have a second meaning in another place. There are better examples. There are more technical examples of this that I can't come up with off the top of my head, but I think you get the idea. If you're using a technical term, make sure that it refers to a single technical idea. One other thing to note when you're designing your API is if you have a similar tool or you're interfacing with another tool that is either outside the scope of your tool, try to keep the naming conventions the same as the APIs that are similar. That will minimize the amount of learning time that users have, as well as if they're coming from some other API or they're trying to plug your API into their API, the naming conventions are the same, so that it's consistent with that, which means that it's easy to learn. I think this is the last one we talked about. So predictable was don't violate the principle of least astonishment. The user should never be surprised by what your API does. We spend a lot of time in our courses talking about performance, about complexity analysis, but the most complexity, how do I want to state this? The worst thing you can do is confuse the end user, because then they won't use your program to begin with, and that's a problem. Don't do things behind the user's back. So you should not be modifying any instantiated code that is publicly accessible without having the user going through one of its methods. So don't modify global or static variables. That's going to make the user wonder how that happened. They're going to try to debug that, and they're going to find that, no, it wasn't something that I did. It's something that the underlying code did. Imagine that you're coding something up and you discover a bug, and for the life of you, you cannot figure out where that bug is coming from. Imagine that it's within the code that is not the code that you wrote, but it's the code that is embedded inside of an API that you don't have access to because it is not public code. How are you ever going to figure that out? If it's an issue with how the API works, the way the user thought the API was going to work versus what it actually did, which was reach behind your back and make a change that caused a bug, there's no way for them to debug that. It relies on their understanding the implementation of your code. And if you're not making that code public, then the user needs to know what your code is doing at all times. Not how it does it, but they need to know what it's doing, and that needs to be embedded in the API. Minimize the use of other interfaces. Don't go out and utilize other API calls within your API. Try to make it self-contained. Why might that be important? I feel like there's something missing from this slide as why that's important. Minimizing the use of other interfaces.
That's if the, like another API,
Yeah,
if the other API changes.
yes, that's exactly right. You're not in control of whether the other API changes. And if your API relies on their API and their API changes, then everyone who's using your code, their code breaks. So you should be responsible for anything bad that happens to people who are using your code. And then, of course, document everything in your API. So this is not documenting your code, this is documenting your API so that other people can use it as easily as possible. Every single class that they can instantiate, every method that they can call, every interface they can create, every constructor that they could use to create a new object, every exception that could be thrown. Absolutely everything should have documentation so that when the user experiences it, they can go back to your API and understand what happened. Whether that was expected or not, exactly what causes that. This is all of the documentation for your code. In stateful applications, you should also mention the associated states that things are in. It should be robust. What happens when the user does not understand your API and does something that you don't expect? You do not want to crash unless there is no possible road to recovery. So yes, lots on error handling, but a lot of this is just make sure that it's complete and that it handles everything that it's looking for and everything that it's not looking for. It should be adaptable. As we mentioned, can be extended but never shortened. So heavily used APIs are going to be extended because you will discover more use cases for your code and want to be able to extend it so that more people can utilize your tools and interface with it in ways that are useful to them and their use cases. But you should never have to rework your API, so you should design it from the first place so that it is extendable. And then, yes, implementation details should not affect the API. So again, you should be able to go gut every single method and class, as long as you're not changing the names, the parameters, the parameter ordering, the returns, the return types. But you could completely change the underlying data structures. You could change the algorithms that are being used, replace one with another. And as long as they're taking the same inputs and produce the same outputs with the same tools, then your API can completely be gutted and changed. Think of it like a full brain and body transplant, with the exception of like the skin and bone structure staying the same. You look exactly the same, but every single organ in your body has been replaced with another one. You would still function, and it looks exactly the same from the outside, but possibly exactly how you work has changed using different muscles. Kind of a strange analogy, but yeah, if your implementation detail affects the API, then it becomes tethered to that implementation, which means that if something better is ever available, if for some reason you need to make a change to that, that's going to create a massive headache for your project. So it should be designed in a way that it is independent from your implementation. Resource management, something that Java does some of for you, but not everything. And you will frequently be using languages that don't necessarily do as much resource management as Java does. So we should understand responsibility. So is it the user's responsibility or your code's responsibility for each of these ideas? So initializing objects. Is it the user's responsibility to make something, or is there a method that is called that makes that object and returns it? Think something kind of like a factory. Maintaining state. So what validates the state of the object is in a good state. So for instance, whose responsibility is it to ensure that a bank account's value is positive?
Customer.
Yes, but let's say you've written some banking code, and either you're responsible for throwing an error when that account value goes negative, or do you want to leave it open to the API to say, I will let you know that the account value is negative, but that is now something that you can program on the outside to handle that in a way that you want. You could then trigger an automated email or automated text message that alerts the user of something from there. And that's something that the end user could be responsible for using your API. You have an exception that's thrown for that, but that exception is not going to crash or delete the account. Or imagine that you wrote this and whenever the account balance goes negative, you alert collections and delete the account. Is there any road to recovery for a bank that doesn't want to do that? Whatever you implement is set in stone that can't be modified. So you can design this in such a way that the user is responsible for how this is handled, the state is handled, to ensure that an account is in good order. Or you could handle that in some capacity. But we have to decide who's responsible for what. That's a design decision. Sharing information between objects and copying objects, who's responsible for that? Is that something that your code needs to be able to handle? Or is this something that the end user should have to implement if it's going to be done in the way that they want to or care about? Sometimes you can get away with both. Here is an implementation of what this will do by default, but you can override it to do what you want. But that would have to be put into your design to allow for that. Sometimes that would lead to some implementation details. If, for instance, you wanted to allow the end user to write an additional class that could be plugged into an interface of yours. Great, except that if they need to plug it into that interface, they need to know all of the methods that need to be implemented, which of course are going to tell you a little bit about the implementation details, potentially, of your code. If it's an interface, not so bad. If it's an abstract class, now it becomes a bit more of a problem. Cleaning up. How is memory deallocated? Java has a garbage collector. We don't have to worry about that too much. Languages like C++ do not. You're responsible for allocating and freeing memory. So is cleaning up your responsibility, or is cleaning up the user's responsibility? Note that again, if you expect your user to clean up for themselves, then they may end up with a memory leak in their program, which is not your API's fault, but you're the one who gave them the power to be able to put a memory leak in their program. If you handle it yourself, now the end user cannot have a memory leak, but maybe there are some restrictions on, is there a use case where they wanted this object to still be around, but it's been cleaned up? You made an assumption for them that they're done with this object, therefore it can go away. Have to design that back into your API. The user should be aware of what they have to do when their objects are going to be constructed and destructed. If your API is not clear about that, then you can see how this would be frustrating from an end user's perspective. Wait, what do you mean I have a null reference? The object is gone. Memory was cleared. So same thing for memory files and global variables. So. languages that require you to allocate resources, free them where they were allocated. So if they're allocated in a class, make sure they are freed in that same class. Make sure that users are aware of return types being reference types or object types. That's kind of necessary from an end user's perspective. Am I getting back my own copy of something, or am I getting back a reference? Any questions on resource management? Or anything else so far? All right, next we have error handling. Make sure errors get caught. If you ignore an error, then that will cause a crash of some kind. You should catch and return to the user some kind of error, and that way they can handle that error in ways that their application determines that that needs. So always, if you're in Java, throw exceptions, find the appropriate exception, make sure that your exception messaging is very clear about what happened. And if you're designing code for someone else, then wherever your code could crash, there should be an exception that is thrown. Don't let the language itself catch something. Always catch it yourself. But just print and fail, not always good. We need to be able to allow programs to recover state, save state, something of the sort. So make sure that you have optionality for that within your code, and or return the exception to the user so that the user can handle that in some regard. So yeah, minimize the amount of print and fail. If a program does not need to crash, it should not crash. A crashing program should be only coming from the point of no return. There's nothing that we could ever do about this. So we will crash. What's an example of that? What's an example of a program state or situation where you would absolutely have to crash?
Iteration goal.
Yeah, that
After you get in an infinite loop.
infinite loop of some kind. So that wouldn't necessarily be a crash. It would be a program going on and on and on forever, which is certainly a problem that needs to be killed at some point. But yeah, think of the state of a program. That's a good idea. But the state of a program being irrecoverable. Yeah.
Something that goes like way out of scope of where it's supposed to be. I mean, you shouldn't ever be in that situation, but if you're off the rails, then there's not much you can do other than just take it up behind the woodshed.
How about a segmentation fault? Everyone's familiar with a seg fault and what a seg fault is? Who can describe a seg fault?
Your program's now taking up more of the stack or heap than it was ever allocated.
Yeah. Yeah. So you're accessing memory that is outside the scope of your program. So you're overriding memory that you shouldn't be. What are you overwriting? Who knows? So we have to catch that and do something about that. Immediately stop, because what is there? That could have drastic effects on whatever is running. It could cause irrecoverable harm.
But that's like C, right? Not Java. C, C++.
Well, it's because Java handles all that underneath the hood.
Yeah.
So Java's API says that's our responsibility. C's API says that's your responsibility. So that's where this decision of do we handle it or do you handle it comes into play. If you handle it, if so Java's API handles that for you, there's no recovery. There's nothing that can be done about it. On C's end, you're responsible for catching that and doing something with it. You need to make it right, which C is not the most accessible language for that reason. A lot of the training wheels, protections are not in play.
Too much freedom.
It's a lot of freedom, and you can do a lot with that freedom. With responsibility, with power comes responsibility. So either you have a language design that is high power, high responsibility, or low power, low responsibility. And different people will utilize different designs for different reasons. But if you're the kind of person who really likes the freedom to be able to manipulate memory addresses and how that can lead to efficiency, then there's a tool for that. If you want to design in such a way that it's impossible for something like that to happen, there is a tool in place that will prevent you from getting in that situation in the first place. Good question online about whether testing frameworks should be visible in an API. That's a really good question, actually. I think that depends a lot. It depends on the tool. If the testing framework reveals a lot about the underlying details, I would say that you do not want your testing frameworks to be public. But you might release certain testing tools that for the kinds of objects that can be made, here is a base test harness that you can fill out, and it has tests written for it with regards to the state of it, with regards to everything that you might expect from that object. And depending on how users use that, they can fill that out with different information. Let's see, if we catch everything here. Yeah, detect errors at a low level, but handle them at a high level. Don't try to handle the exception where it occurs. If we're deep inside of a method that's inside of a method, we're deep into the call stack, and an exception occurs. It's better to handle that at a higher level than a lower level, because when this exception is thrown, there are many different ways to call this inside method. We want to find where is the innermost place where we know exactly what happened. And that's where should be handling that exception. Does that make sense?
So on the outer level, you want to handle it?
You want to handle it as innermost as possible, but where you for sure know, because otherwise you might only be able to throw a generic exception. But if you can come up with the reason it happened, a lot of the why is embedded in the outer shells of that method call. So you can collect data as this crashes, as that crashes, as that crashes, as that crashes. You're gathering information about what happened on that call stack. And by the time you reach the outermost method, then you have enough information to relate to the user. Here's exactly what happened. Can we try this again? Yeah, the error should be handled by the routine that is calling it, not the underlying. So where the crash happens, whoever called that handles it. The error is going to cause this method to be unable to continue, but we move out to the next layer out, and that understands the context for what did I pass this? What was I expecting? Why did this error occur? I can now relay that information out. As soon as an error occurs, report it. Don't make any assumption about what the user is doing or what they meant when an error occurred. Sometimes this means to fail at compile time. If you're using static types or generics, then at compile time, you can have failures. How do we handle errors? Return values should always be in a form that the calling function can use. So a method that returns a positive integer should return -1 on failure or something that indicates failure, but it's the same return type. Don't throw an exception. Return a failure code. Return as much useful information as you can. So you might have different codes, -1, -2, -3, that mean different things within that the calling program can determine an error occurred, here is what that error was, but it's all in something that now the code can read and use. We haven't had to throw an exception or cause something that, let's see, sentinel values. Yeah, pairs are another parameter to indicate errors. All of that is good. An error wrapper function can work. So something like you could design a decorator, one of which is an error. That seems unnecessarily complicated in a lot of cases, but it's a thing.
Would that work if you're trying to say build up a list of exceptions to start saving to a file to be more easily read, that kind of thing?
Yeah. So exceptions, some kind of issue with the underlying state. So we have a programming construct causing that exception, set the value, either return it or have some way of catching it and doing something when the exception is thrown. If that exception is terminal, make sure that information about the failure is embedded in the exception. And that means that if it can be handled, then we can attempt to repair that information within the scope of the program. Or if it does crash, then the end user can use it all for debugging if the issue is on their side. So something like there's an exception, you're trying to access memory that's outside of the scope of this list. Then you can just cancel that request, submit an error message of some kind because that exception was caught and handled. It's not causing the program to crash because we caught it before we tried to do it, but we might have to reprompt the user. We might have to do something that now that error can be handled. If we know exactly what it was, then we can tell the user you were trying to access this index when your list was of size that. And they can see, oh, this is an off by 1 error. Wait, how was I trying to access index 6000? This array is of size 4. Something really bad happened in here. But the more information you give the user, the more they're going to be able to utilize that information to debug their code. Exceptions should generally be unchecked. Process them globally rather than have explicit checks over and over and over and over again. Makes sense. They should only be used in especially exceptional situations, meaning that there is no hope for recovery and or there is something that we cannot continue. That's the better way to state it. If the program cannot continue in its current form, then throw an exception. It's not a control structure. You don't want to use an exception to figure out where should my code go. If this exception has value this, then execute this code. If my exception has value that, then execute that code. That is equivalent to something like a goto in code that is just unnecessarily complicated. So the exception should be used as an error handling construct, not as a way to split your code as an if else. It should not be used as a loop. It should not be used as a goto. It should be used to identify an error and to handle that error. To reconstruct, take your program state, turn it into a fixable state, and then proceed. Does that make sense? Does the difference of that make sense? Should be something wrong with the codes, something wrong with the state, such that it cannot continue.
So what you're saying from that is don't use it as the if statement as
Yes.
a branch.
Yes.
Okay.
Don't over-engineer your exception. There should be a single exception for a single type of issue. You should not have to parse your exception as a control structure. Either throw different exceptions for different issues, but don't throw a single exception and then use it as a control structure to identify the components of your exception. And then, yeah, do not use exceptions for expected return values. So your method that you write should not return an exception. It should not be expected that your method is going to produce an exception. It should always be exceptional behavior when your program produces an exception. There's always a better answer or a better solution to returning an exception as every possible path through a method. Any questions on that? How do we feel about API design as a whole? If I gave you some code, would you be able to write an API for that code? Design a reasonable API with all of this in mind?
Okay, but I'll complain the entire time.
Depends on the complexity.
Question.
If I asked you to write an API for your UML editor, how confident would you be to allow that to be extended and used from an external perspective? There's not a ton that you can do. It's not really a tool that other people can extend yet in a particularly useful way, but you can imagine that you were designing it as such. It's now a tool that other programmers can use and import as they do something else, bigger in scope.
So they could create a UML diagram using an API.
They could embed the UML editor in their web application on their website. They could
Well, kind of making it the basis of their thing, like GNOME acts like.
Yeah.
Fair enough.
Yeah, so it would be possible to do this, and to do that, to share your code, you would not want to make it public or open source necessarily. You would want to license it, and you would want to say, in order to use this, you can use my public-facing API, but I'm keeping my code near and dear because I don't want this out there. I don't want there to be 10,000 clones of my intellectual property. That also allows you to put your code behind a paywall where you can license your API and charge a yearly fee or monthly fee for the use of your API. Where there needs to be an account in order to access the documentation and the code, then there's a fee to it, and that is very common. As an example to that, I guess I can talk about a passing interest of mine, which is college basketball analytics. I just like any analytics, honestly. But if you're familiar with Ken Pomeroy's site for college basketball, why not just show it? Because we have a little bit of time at the end of class.
So like what players scored how many points and history of that stuff?
So, yeah, Ken Palm gives you a significant amount of stat for free, which is just the associated net rating of each team in Division I college basketball, but their offensive rating per how many points are they expected to score in 100 possessions against an average team, a team that has a net rating of 0. How many points would they score? Defensive rating is how many points would they give up in 100 possessions to a team with a net rating of 0. Average, their adjusted tempo, how fast do they play on average? Luck, how close were their victories and defeats? Strength of schedule, non-conference strength of schedule, and every year. But of course, each of these teams has significantly more information embedded in that about on a player-by-player basis. But you can purchase a subscription to view those stats. But they just released their API access. So I could write my own code that utilizes their code to calculate new and generate new stats of my interest. I could create custom displays of information based on the information that they collect. So I wouldn't have to figure out and go through the process of trying to scrape all of the data, and I would have access to all of their analysis algorithms for coming up with the associated value of players, of teams, of this entire college basketball environment, but I would have no access to their code. I could interface with it, and I could use their intellectual property to create my own, but I wouldn't know how they did what they did. I would just have access to it. I could add my own how and interpret it and use it, but to do so, it would cost me some money.
Like
And-
$100?
Yeah, that's not that expensive for something that if I felt like I had some insight, if I could use this information and extend it in some capacity, there's value in that.
Like sports betting.
Sure. Yeah, if I were a betting company, I could now access all of the information that is hidden behind a paywall of how this actually all works. Yeah, that's a great example. Not that I like sports betting at all. I think it's one of the world's greatest evils, but yeah, it allows you to create a company out of someone else's intellectual property. And if you can come up with this statistical collection on a real-time basis, then you can license that to other people and sell your ideas. But imagine that if all this were public, would they be able to make any money off of this? I could just see their algorithms, take their algorithms, use it for my own good. Why would I pay them for that? Even if it's licensed, unless I become aware of it, then there's a legal issue. But the fact that paywall is there, I can't access this cool information for my own good without paying them
So that's
or
stuff is
hacking
not,
their servers.
so that stuff is not public information?
Nope.
The scores of,
Oh, the scores you can pay on a year-to-year basis
no, I
to
mean like,
access the.
if you want to do it yourself, like scrape.
Yeah.
Is it public?
You would have to make your own.
Yeah, you have to scrape from this public site. You have to pay them money to get access to the more detailed statistical views.
No, I mean, where do they actually get their information?
That is a good question.
Okay.
I don't know. That's embedded in their implementation detail.
Might say at the bottom of the document, you can scroll down.
Stats provided by Stats Perform.
Yep.
So another company or maybe an API,
Yep.
magic and details.
Wall Street has a lot of the same model for what is it? It's like a $10,000 lease for the API that's super rapid for them getting the updates.
Yeah.
And that's not per year, that's per terminal that's running it.
Yeah. There are lots of different business models that you can use once you have access to an API. You can allow a certain number of API calls. For instance, ChatGPT will monitor how frequently you call its API, and you get a certain amount of API access for a certain amount of money.
All the tokens.
Yeah. So that's an option. We are out of time. We'll come back to this on Thursday. We have our design meeting tomorrow. Yeah. And big purpose of design meeting for this sprint, I want to ask you about what feature you would like to implement for extra credit for this last sprint. So if you're going to do that, make sure that you talk to your group about it and come prepared with some suggestions.